Okay, we're doing Inclines 3. Here we have a box sliding up the incline, no more wheels, and it's sliding up the incline. So it's going up and it's slowing down. So I'm going to say, so I can know that the acceleration is that way, because it's slowing down. It's got to be opposing the velocity. So free body diagram, again I'm going to draw the angle really shallow so that I can tell where it is on my diagram. And I'm going to draw the normal force perpendicular to that angle. And this time I also have kinetic friction. It's opposing the motion, so it's going this way. And I'm going to just go ahead and call it mu sub k times n because I know that's how big it is. I'm going to move my mg over to the label to the other side so that I can break this up and not like write all over the, not to have the two vectors on top of each other here. So I know it's the skinny angle is the theta, so it's that one. It's mg cosine theta. It's mg sine theta. I'm gonna call up the ramp positive because if I'm gonna do any kinematics with this, you're far likelier to forget to make the velocity and the displacement negative, which they need to be if the positive is down the ramp, than you are to forget it in the F-net, which will give you the acceleration. So my acceleration will come out negative, but that'll be easier for me to work with, I think, in the kinematics. So perpendicular to the ramp, have n going out, mg cosine theta going in, and it is balanced because the acceleration is just parallel to the ramp. Parallel to the ramp, I have negative mg sine theta because it's pulling it down, which is not my direction of positive, and minus mu sub k n, again, against my direction of positive. It's unbalanced. I have two forces down the ramp and none up. I know it's accelerating down, so definitely unbalanced. Then equals ma, solve for the block's acceleration. I'm going to need to solve for n first to eliminate it, and then substitute it in. Divide by m, and I'm going to factor out a g. So if you notice one more time here, we got a function of or a multiple of g times this sort of dimensionless thing here that has to do with the angle. It also has to do with the kinetic friction coefficient. That's the kind of thing that happens a lot. If the acceleration is free fall acceleration times some thing, which is definitely going to be less than 1. Here in particular, it's negative 5.3 meters per second squared.